Now I'd like to discuss, and so when you are reviewing, some of these measurements, some of this data about our undergraduate program, then it comes to mind, okay, so we probably need to review certain things, we probably need to brainstorm, we need to make some considerations. I think that it's important to set goals in terms of producing workforce, but some of these things are also in terms of finance, and there are business models, in terms of how many credit hour production a department keeps, and constraints that are very real that have to do with budget cuts and things of that sort, right? So basically, we need to grow the number of mathematics majors, and we think, and we also need to grow the number of mathematics and statistics minors. So about the mathematics majors, the joint mathematics meetings that will happen in January of 2019, they have a session, contributed paper session, called Innovative Curricular Strategies for Increasing Mathematics Majors, right? So I think this is, I'm just bringing this to your attention in the sense that these issues or these problems that we are facing here, we are not the only ones, and this is receiving some consideration at a national scale. And this is a case in point, a whole session dedicated to this very same issue of how to gain more mathematics majors. So here are some of the, in the synopsis of this session, here are some of the things that they mention with those goals in mind. About to grow the number of mathematics majors, consider alternating entry points to the mathematics major. Pathways should also be alternated. Pathways to college-level math courses and through these courses. First-year seminars, and this kind of relates to something that Rick mentioned earlier, in terms of identifying freshmen or so this is a point about seminars that are targeting majors in science, technology, engineering, and mathematics. For a freshman student, the first 2 semesters are going to have a lot of general education requirements, and so certainly a student that, that summer prior to their first fall, they may say, yeah, I want to be a physics major. It wouldn't be that surprising that by the end of the year, they change to another major. It may be math, it may be chemistry, or maybe something else, and they're still on track, right? So they're pointing out, you should identify the first year students that are either have declared STEM major or are very likely to declare STEM major, and then you should have certain seminars that are only targeted to those students. Retention, recruitment, graduation of specific populations is also another thing to consider. So these are like very brief points from this session to take place in January of 2019. Now, as far as some ideas to increase or to grow the number of mathematics minors, I have, in these 2 slides, I have some ideas of my own with the minor exactly as is currently in the catalog. So I had mentioned that my way of explaining the mathematics minor is that it has phase 1, phase 2, and phase 3. So that's what I'm illustrating here in rectangles. Phase 1 is the same. Every student that's completing a minor with us, a minor in mathematics, has to take Calculus 1, Calculus 2, and linear algebra. Now, here's the first example. They go phase 1 in that order, and then in phase 2, they take mathematical reasoning, okay? And then in phase 3, they take combinatorics, they take graph theory, and then they take algebra. So if they do the sequence in this way, in which they have 3, 1, 3, so this would be a way of completing 23 credits, a total of 7 classes, and this is a way of fulfilling the requirements for a minor. And if they did so, this is a minor that resembles the concentration that's called mathematical sciences. Okay? Here's another example. Phase 1 is exactly the same. Phase 2, they would take differential equations. And in phase 3, they would take mathematical modeling, numerical analysis, and numerical linear algebra. So this is another way of doing a 3, 1, 3 sequence. They complete 23 credits, that is 7 classes. And this version of the mathematics minor resembles the concentration that is called computational applied mathematics. So, we have 4 concentrations, so you may expect that I have 4 examples here in this portfolio. So here's the next one. Phase 1 is exactly the same. Phase 2 is probability with calculus. And phase 3 is statistical modeling, statistical machine learning, and introduction to stochastic modeling. So this is, again, another scenario of having a mirroring the concentration that's called statistics concentration. There are 7 classes completed, and they add up to 23 credits. So the last scenario of this portfolio is slightly different. This will have 24 credits, and the first phase 1, they take 3 classes. In phase 2, this is one difference, they would take 2 classes. So unlike in the previous scenarios where they go 3, 1, 3, here they go 3, 2. So that's a total of 5 classes so far. And in the next phase, phase 3, they take 2 classes. So they still complete 7 classes. Here they're doing, in phase 2, calculus 3 and mathematical reasoning. And then for phase 3 of this version of the minor, they take geometry, and then they take history of mathematics. And this would be a version of the minor that would have some resemblance to the concentration that's called mathematics education. There are still 7 classes, but there is an extra credit here because calculus 3 is a 4 credit hour class. Okay, so these ideas, these portfolios I just discussed, do not involve making any changes in the catalog. This is as the catalog is with the rules as they are. These sequences could generate, different versions of the minor. But I have some additional ideas here I thought I would discuss or share with you. I think the minor is like a sampler and should be a succinct, it's an experience where the person has, for me, the main goal is to provide skills, is to improve skill sets, to provide training, but I still think of this as being a succinct sampler of an experience that gives them some idea. So the main thing for me in a minor is to have the 3 classes that are upper level. So I would think of another idea here in which the number of credits is reduced from 23 or 24 to 20 with the intention of reducing the total number of classes from 7 to 6, provided that 3 of those classes are still upper level. But to accomplish that, we would have to change 2 classes that are currently 2,000 level into 3,000 level classes. I'm specifically referring to probability with calculus and to differential equations. Now, making these changes would have to be done in a way in which we honor the current articulation agreements we have with a network of community colleges, okay? In a way in which, yeah, sure, we change the name of the class, change the code of the class, maybe change the contents of the class, to be fair. We're increasing a little bit the level of the class, but our transfer students that are coming from these community colleges do not see any adverse effect. In other words, that we would grandfather in and honor, you took that class with that name and that code in your home institution, okay, we give it transfer. You have the credit here. However, one way of doing this would require to, okay, so let me make another point. You could, or you may start thinking, like, the first issue here that I have is that you're saying that this person took this sophomore level, sophomore level class over there, 2,000 level, and now they're getting credit here for the 3,000 level class. Oh my God, this doesn't make any sense. This type of thing happens commonly when substitutions are made for international students that are coming from an institution where the official language is not English, where you're reading a transcript that has an official English translation, but it's not clear, even from that translation, what is the content of that class and what is the depth of the content of that class in that other country. And so at some point, somebody has to, it's a very delicate balance to maintain. At some point, somebody has to decide, okay, we're going to give this credit, we're going to make this substitution, because part of the priority there is the student is already here or is on the way here, and you want to keep them, as much as possible on a successful path of academic success. or viable part of academic success. So, but there are substitutions of a similar nature that happen sometimes in with universities from, the South Pole or the other parts of the world. So, I think the key would be to make sure that those community college transfer students, even though they receive the credit, this is not going to be any financial cost to them, but they would need to we would need to provide them with some type of like a study guide or some type of leveling, self-paced leveling plan in which we can make it sufficiently clear. You don't have to take that class again. Certainly, you don't have to register and pay. But what we could do is that we can give you this like study guide with a couple of books. We have a Center for Academic Achievement. We have an army of graduate assistants. We can set up some one-on-one, meetings with tutors. But the key is that you are going to have to take charge. This will not cost you any money, but it will certainly cost you an investment of time and energy in which you're going to have to bring yourself up to speed, with some of the things about probability, with calculus and differential equations, given that here we have a little higher level than the level that you had in your previous home institution.